Okay, so we left off class talking about the powers of I. Remember that I's are cyclical? I mean, cycle, right? Cyclical cycle. So they go in rounds of four. So I, -1, negative I, 1. And then I, -1, negative I, excuse me, 1. So basically, we can then use that to identify what is I to the whatever power. So I to the 15th, we can say, well, that is I to the 4th times I to the 4th times I to the 4th times I cubed, because 4 plus 4 plus 4 is 12, plus 3 is 15. So another way to think about this, so I to the 29th, is that a student showed me one time, is like a baseball field, baseball diamond. So like home, first, second, third. So if we think of first as I to the first, that's I. Second is I squared. Okay, so think of that as -1. I cubed is negative I, and then home base would be I to the 4th, or just 1. Okay, so this, thinking of it in terms of this way, you think using the remainder example. So I to the 29th, so 29 divided by 4 is equal to, sorry, let me grab my calculator. Can you see that? Yeah, hopefully. 29 divided by 4. Okay, that is 7.25. So 25, that's 1/4. So that is 7 and 1/4. Okay, so that means there is one I left over. So that would just be I. So another way to think of it in terms of the division is that home base is also, if I have a 0.00, I have a 0.25, a 0.50, because 1/4, 25, 2/4 is 50 cents, 3/4 is 75 cents, right? So, and then if I have a dollar or 00, right, that is 1. So 100 divided by 4, and then so I to the 100th, I to the 47th, I to the 1010th. I want you to try it. Any method you want. Pause the video and then come back. Okay, so if I do 100 divided by 4, right, well, it's not too hard, but let's look at it. 100 divided by 4, 25. So technically that's 25.00, meaning there's no remainder, so that is 1. So there are 25 I to the 4th, essentially. So it's 1 times 1 times 1 times 1, da 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 da. How many times? 25 times. Okay, so I to the 47. 47 divided by 4. Let me change calculators. 47 divided by 4. So 11.75. So again, that's equivalent to I cubed, right? 75 cents, if you would. 3/4 I cubed, so negative I. And then 1010 or 1010 divided by 4. So 1010 divided by 4 is 252.5, or if you would think 50 cents, or 2/4, right? So that would be up here, second base, if you would, in terms of the baseball metaphor. So then that is I squared, or -1, because I squared is -1. So I hope that helps. Either way you like it, the remainder version or using that kind of baseball metaphor. But that finishes the complex numbers. So then we'll dive into quadratic. Give me a second to get the paper. Here we go. Quadratic equations. So learning objectives: solve quadratic equations by factoring using the square root property, completing the square, and by using the quadratic formula. So you're probably actually familiar with a bunch of these already, especially the quadratic formula. If not, that's fine. That's why we're going over it. Completing the square might be new, and the square root property, you're probably at least semi-familiar, but we're gonna go over it, obviously. Then talk about the discriminant, and then solve applications. So first, the zero product property. So zero product property essentially says if A times B is equal to 0, then A equals 0 or B is equal to 0. So what that allows us to do is if I have factors that equal to 0, then that means one or both are equal to 0. So this allows us to factor quadratic equations. We set one term equal to 0 and solve. We set the other term equal to 0 and solve. So the definition of a quadratic equation is let A, B, C be real numbers such that ax squared plus bx plus c is equal to 0. So the difference between a quadratic and linear equation is that now we have our highest power to be a square, right? So that is one of the main difference. The quadratic equation is also that bowl looking shape, if you're familiar, right? You have the bowl or umbrella. So if I want to solve quadratics using factoring, and this was what one of that I guess like pre-homework set was about. If you're not used to factoring, please go back and look at it. But we want to move all the terms to one side because we love quadratics at 0. Then we factor, and then we will set each factor equal to 0 because we are allowed to with the zero product property. So here, if I have x squared plus 8x equaling negative 15, well, what do we love quadratics that equal to? 0. So we want to add that 15 over. There we go. And now, if we can, we want to think. So we have x and x because we know the first terms multiply to give us the first term. So x times x is x squared. Then back here, we need two numbers that multiply to 15, yet add to 8. So I'm thinking 5 and 3. Because 5 times 3 is 15, and they add to 8. So we both also need a plus and a plus because I need either a double negative to give me the positive here or double positives to give me the positive there. So if this was a minus 8x, I would need minus 5 plus 3. But since it's all positives, we want the positives. So now from the zero product principle, we are allowed to take each factor, set them equal to 0, and solve. So x is equal to negative 5 and negative 3. Okay. Okay. So next, if I have, let me zoom in, sorry, just a second. Much better. So if I have 4x squared plus 15x plus 9, we can do this several different ways. Change colors. So we know we still have two factors, okay? So an x and an x, but now it becomes, is it 2 times 2 or 4 times 1? Because 4 has two factors, right? 4 is either 4 and 1, and 2 times 2, that equals 4. So if I have 2 times 2, or if it's 4 and 1, then again, we need the combination of the back two numbers to multiply to 3, but in conjunction with the front two numbers to add to 15. So if we practice with this one, let's say 9 is 3 and 3, but it could also be 9 and 1. Let's just pretend. we're just practicing. So more of the guess and check method. So 2 times 3 is 6. And then 3 times 2 is 6. So that's 6 plus 6, which is 12. So that's not the case. So what if it's 2x and 9 and 2x and 1? Well, 9 times 2 is 18. So plus or minus 2 is either going to be 20 or 17, because you're either going to add 2 or subtract 2. So it's not that one. So it's got to be 4 and the 1. So let's see. So if it's 3 and 3, let's try. So 4 times 3 is 12. And then plus 3, yeah, it's 15. So we have plus and plus. There we go. So now zero product principle says 4x plus 3 equals 0. And x plus 3 equals 0. So we solve. So 4x equals negative 3. So x equals negative 3/4. And x is equal to negative 3. Ta-da! We can also do the AC method using this as well. Okay. There's also something called the AC method of factoring, which means you take A and C, you multiply. So 4 times 9, if you're not familiar with the 9 stroke, right? So you put your fourth finger down, that's 36. And then the factors of 36, see, we have 36 and 1, 2, and why my brain can't think, 18, 3 and 12. Let's see, let's just stop there. So then we would notice again that we have 12 and 3. So here for the AC method, you say, okay, well, 36 plus or minus 1 is not going to work because that's either 37 or 35. 18 and 2 is not going to work, again, because that's either the 20 or the, what was I saying? Oh, 16. And 12 and 13 does work because that's 15 or, let's see, 9. That's the 15. So this tells us that is what our x terms are. So this then becomes our 4x squared plus 12x plus 3x plus 9 equaling 0. And then we would do what we call factor by grouping, which is technically what we're doing in a couple of classes, but just to get ahead of the game. We factor out everything we can from the first two, so that would be a 4x. And the quote leftovers would be an x plus 3. And now we factor out everything we can in the back term, but with the caveat that we need x plus 3 to be left over, so to speak. So that means we factor out a 3. So now, why it's called factor by grouping is that here, now the front term and the back term both have x plus 3 in common, so it is the new factor. So up and over, I have x plus 3 now times 4x plus 3, which is what we got above. Oops, let me scoot. Yay, isn't that fun? So AC method. Okay. Move my papers over. Sorry, y'all. Okay, so now using the square root property to write in the form something quantity squared equals a number. Then we want to square root both sides, not forgetting the plus or minus. And then we finish solving if needed. So that means usually like adding, subtracting, dividing anything back over. So essentially we want just the squared term equaling a number. So we want to move everything over first. So for A, let me get it out of the shadow. That means subtracting that 1. So 4x squared is equal to 6. Then we divide by 4 because we're just trying to isolate the squared term. That's 6/4 or 3/2. Now we're ready to take the square root of both sides. But again, not forgetting the plus or minus. So this says x equals plus or minus the square root of 3/2. But we don't really like roots in the denominator. So we are allowed to split division roots into their own term. So this is called rationalizing. Rationalizing. What we do is we throw in that special form of 1. We throw in that special form of 1. We want root 2 over 2 specifically because, again, this is root 2 times root 2, which is equal to root 2 squared, which then just gives us 2. So here, this is root 3 times root 2, or root 3 times root 2, excuse me, under the same radical, because with multiplication and division, you can separate them like this. Or root 6, not forgetting the plus minus. So there we have it. So we would say that this is equal to plus or minus the square root 6 all over 2. So now with something like B, we have 4w plus 1 quantity squared equals 5. So here, again, the square term is isolated. So we're just going to dive right into taking that square root of both sides, not forgetting the plus minus. Let's change colors. So this says 4w plus 1 is equal to plus minus root 5. And so now this is where we finish solving. So we subtract a 1. So 4w is equal to plus or minus root 5 minus 1. Or realistically, we like -1 plus or minus root 5. We like that plus or minus to be second, but it really doesn't matter. Just as long as we know that the root is only over the 5, okay? So if you write it like this, just make sure that it's crystal clear the root is only over the 5. And last but not least, divide by 4. So w is equal to -1 plus or minus root 5 over 4, and that's it. Perfect. And we cannot simplify because 4 doesn't go into 1, and there's an invisible 1 right there. Okay, so example 3. The volume of a right circular cylinder is V equals pi r squared h, where r is the radius and h is the height. Solve for r. Okay, so very similar to what we were just doing, we want to isolate that squared term. So since this is pi times r squared and h times r squared, we can divide them over. So v over pi h is equal to r squared. Now what do we do? Square root both sides, not forgetting the plus minus. Although we don't technically need the plus minus over here because the root is undoing the square. So I have plus or minus square root of v. I'm just going to go into the square root of pi over h is equal to r. Remember, I split this up because we don't like roots in the denominator, so we're going to rationalize. So I'm going to multiply by the denominator, root pi h over root pi h, so that I have plus or minus the square root of v pi h over pi h is equal to r. Perfect. Woo! Okay, so I'm going to pause here to clip the video.